assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
For this problem, there is a block that is suspended from a spring that has a mass of 4 kilograms, and the spring has a spring constant of 500 newtons per meter. And then directly below, a bullet is fired up into the block. The mass of the bullet is 50 grams or 0.05 kilograms, and the bullet is moving at a velocity of 150 meters per second. And we're being asked to figure out first, what is the amplitude of the now oscillating block, and then second, what percentage of the kinetic energy of the bullet is transferred into mechanical energy of the oscillator. So the first thing we have to do is we need to work through to find what the velocity of the block is after the bullet hits. And we're going to use the idea of conservation of momentum. So we'll have the equation mass times velocity equals the mass, and that's the mass of the bullet times the velocity of bullet, will equal the mass of the bullet plus the mass of the block times the final velocity after the bullet strikes. And we're going to solve for the final velocity, so we're going to solve for VF here. So we're going to rearrange our equation so that our VF equals the mass of the bullet times the velocity of the bullet divided by the mass of our bullet plus the mass of our block. And substituting in our values here, we get our final velocity is going to equal 0.05 kilograms times 150 meters per second divided by 0.05 kilograms plus 4 kilograms, giving us a velocity of 1.8519 meters per second. So now that we have a velocity, we can determine what the amplitude is, because we can put our kinetic energy minus our potential energy equal to 0. So we're going to have 1/2 mass of the system, which is the block plus the bullet, times the velocity final squared, minus 1/2 the spring constant times our amplitude squared equals 0. And we're going to, in this case, solve for our amplitude. So rearranging our equation, we're going to have our amplitude equals the square root of the mass of our system times our final velocity squared divided by our spring constant. And so substituting in those values, we have amplitude equals 4.05 kilograms, which is the mass of the bullet plus the mass of the block, times the velocity that we just calculated, so 1.8519 meters per second squared, divided by our spring constant, which is 500 newtons per meter. And we get that our amplitude is going to be equal to 0.1667 meters. Now, for the second part, we're being asked to figure out what the percentage of kinetic energy was transferred into mechanical energy for the system. So in this case, we have our kinetic energy equals 1/2 the mass of the bullet times the velocity of the bullet, and our total mechanical energy is going to be 1/2 the spring constant times our amplitude squared. And we found the amplitude in the first part, so now we can actually substitute that in for the second part. We already have our spring constant, we have the mass of the bullet, and we have the velocity. So to find the percentage that was transferred, we are going to divide our mechanical energy by our kinetic energy. So we are going to have 1/2 kxm squared divided by 1/2 mass of the bullet velocity squared. Oh, I forgot the square up here. Velocity squared. Our 1/2s divide out, which makes it a little bit easier. And substituting in, we have the value 500 newtons per meter times 0.1667 meters squared, because that was our calculated amplitude, times 0.05 kilograms times 150 meters per second squared. And when we calculate that out, we get that equals approximately 1.2%. So approximately 1.2% of the kinetic energy of the bullet was actually transferred into mechanical energy.